You must be familiar with dyes, right? There are distinct dyes for each color. Have you ever thought about what gives them color? Yes, these different colors are due to the presence of different functional groups present in each type of dye. For example, para-hydroxyazobenzene is present in the orange dye. In this video, you will get introduced to diazonium salts which are used as precursors for the synthesis of azo dyes. Diazonium salts have the general formula Rn2 plus X minus. Here, R stands for an aryl group and X minus ion may be anions like chloride, bromide, hydrogen sulfide, etc. The N2 plus group is called the diazonium group. Diazonium salts, say benzene diazonium chloride, may be prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. Nitrous acid is produced in the reaction mixture by the reaction of sodium nitrite with hydrochloric acid. This conversion of primary aromatic amines into diazonium salts is known as diazotization. Now let us look at few of the properties of diazonium salts. Diazonium salts are colorless crystalline solids. In dry state, it decomposes. Hence, diazonium salts are immediately used after its preparation. In fact, they are stable in the cold and react with warm water. However, diazonium fluoroborates are water insoluble and is stable at room temperature. The chemical reactions of diazonium salts may be looked as reactions involving displacement of nitrogen and those with retention of diazo group. First of all, we will examine the reactions involving displacement of nitrogen. For simplicity, the diazonium salt involving benzene ring is denoted as ArN2 plus X minus as noted here. Now, the Sandmeyer's reaction involves the displacement of the nitrogen of diazonium salt. Here, nucleophiles such as halides or cyanide ions are introduced in the benzene ring in the presence of cuprous ions. Alternatively, Gutterman reaction introduces chlorine or bromine in the benzene ring. Here, the diazonium salt solution is treated with hydrogen chloride or hydrogen bromide in the presence of copper powder. Iodination of benzene ring is achieved by reacting diazonium salt with potassium iodide. When diazonium chloride is treated with fluoroboric acid, it yields diazonium fluoroborate. When heated, this diazonium fluoroborate decomposes to aryl fluoride. The diazonium fluoroborate, if heated with aqueous sodium nitrite solution in the presence of copper, it gives nitrobenzene. Diazonium salts may be reduced to benzene in the presence of hydrophosphorus acid or ethanol. Also, diazonium salt solutions are hydrolyzed to phenol at about 283 Kelvin. Diazonium chlorides may be coupled with phenol to form para-hydroxyazobenzene, which we have mentioned in the beginning of this video. Here, aromatic rings are joined through the N double bond N bond as you can see here. Such azo products are often colored and are used as dyes. A similar dye is para-aminoazobenzene. This is formed by the electrophilic substitution of diazonium salt with aniline. Now tell me, how will you achieve this conversion? Here is a small hint for you. Now let us summarize what we have learned.
Manorama Horizon. Learning made simple.